Hello everybody, we're going to be talking about some dental materials today, and our first item on the docket is to expand on the impression materials that we learned about the last time we met. Long time ago it seems like. So the first one we're going to talk about today is called polyether, and I'm going to be just going off of what's in your module on page 12-7. So this is kind of how we used to do it in class, and given the circumstances, we're not going to make a PowerPoint for this at the moment, so we'll just kind of keep doing what worked in the past, and we'll see how it goes. So for polyether, there are some name brands that you should be aware of, such as Impergum, Polygel, and Permadyne, which are listed on your outline. Impergum and Impergum Penta Soft Quick can be placed in the Penta mixing machine that we have in our dental laboratory. That's on the counter that some people have said looks like a snow cone machine. There are newer formulas for that, which makes it more flexible, easier to remove from the mouth, as well as more pleasant taste. So if we were at school, once we get done with this module of polyether, you would normally taste this so that you could see how pleasant of a flavor this material has. Anything that has penta behind it means that it is in the version that can go in the automatic mixing unit. The NF is going to indicate that it is a no frills type of impression material, meaning that it's going to come in tubes. So a base and a catalyst, you're going to express out onto a paper pad just like you did with the polysulfide, and then you will mix it with a spatula. Permadyne is a type of polyether, and that can come in the penta type of mixture or in tubes. So depending on what the doctor's preference is going to be the type of impression material that you either mix or load, depending on how much money they want to spend. Polyether is a relatively expensive impression material in the realm of that world, but it is a very, very good impression material. These used to be supplied in a two-paste system, a base and a catalyst in a tube. Now it's a base and a catalyst that can be supplied in the Pentamix machine in those little foil packages. They base and catalyst come in those collapsible tubes. They can come in different viscosities, so the light viscosity, medium viscosity, or heavy body. The base is consisting of a monomer, which is ethylene amine group, and then there's a silicone dioxide, which provides consistency as well as stiffness for this product. Then there's also a plasticizer that aids in the resiliency of the material to help it snap back to its normal and original form once it has been expanded and removed from the oral cavity. The catalyst causes a chemical reaction to occur. It causes the initiation and acceleration of the set of this material after it is mixed and placed in the mouth. There is silicone dioxide in the catalyst, as well as sulfonic acid ester in the catalyst, and then another type of plasticizer to provide resilience for the material. And then you can add, if you're mixing this by hand, a modifier or a thinner for this material, which is added to reduce its stiffness and reduce its viscosity of the material, and also increase the working time and the flexibility of it. So if we needed to apply this material over the entire arch, if we're doing a full mouth reconstruction, we can add a little extra working time to the material by adding this modifier or thinner to our original mix. It's added in amounts up to the equal lengths of the base paste that is used, and this, again, remember, is only for the types that are expressed out of the tubes, not from the Penta machine. This material does increase water absorption when the thinning agent is used, so it's going to be soaking up saliva from the patient's mouth, and then depending on what material is used for infection control, it can also absorb some of that water as well during the infection control process. Next is the auto-mix cartridges with mixing guns, tips, or syringe tips. These are going to be used very much more popularly than material that is expressed out of a tube. Most offices are going to rely on the mixing tips and not on you to spatulate that material and get it into the patient's mouth. The mechanical mixer, or the Pentamix with the foil bags, was very popular probably 10 years ago. I would imagine with the onset of digital impressioning that is even going to be coming as an obsolete item in the dental office at a pretty quick fashion. Properties of polyether material: it's used for partials, crowns, bridges, and inlays. So a lot of the fixed types of restorations that you are going to be seeing in your dental offices, polyether is a fantastic product to use for those procedures. The working time is the shortest of any type of rubber impression material, which is 2 to 3 minutes. So if your patient has a gagging problem, if your patient is uncomfortable, if we need to take a re-impression, this material works really nice because of the short working time. But that means that you also have to be very accurate and careful so that things are mixed properly and that we get the impression material where it needs to be before it begins to set. It is available in low to high viscosities. It has a very high stiffness. And the newer products are not as stiff, and some doctors really like the fact that it is very rigid because of the fact that they can pour it and manipulate it, and it can be poured and poured and poured and poured and not really affect the amount of times that it can be poured if necessary. The lower flexibility may cause problems in the removal of the impression from the mouth. It needs 4 millimeters rather than 2 millimeters of bulk accommodation recommended for this type of material because of how rigid it is. It does absorb water, as I stated earlier, so do not store this product in water once it is set because it will swell. It should be washed and dried after removal of the mouth and disinfection so that the excess water that's sitting on the impression will not be absorbed into the material. It is advertised as being hydrophilic, so if you remember from way back in dental lab, we talked about hydrophilic, meaning that the material likes to be in the presence of water. And this is a little bit more true for polyether than any of the other materials, but it simply stated that hydrophilic means that it has good wetting properties. So we can put something on this material before we pour it, and that allows the stone or the gypsum product to flow in and around the material better than if it was hydrophobic. This material is easy to mix, and since it is so hydrophilic, it is easy to pour it with the gypsum product. The setting time from start to finish is 6 to 7 minutes, and we can purchase a faster set polyether where we have 1 minute of working time and 4 minutes of set time. The mixing time for this material is 30 to 45 seconds, so it is very fast to get this to be ready to be put in the patient's mouth. This can be repoured and poured up to 2 weeks following the time that it was removed from the patient's mouth. It has incredibly excellent dimensional stability as well as reproduction of detail. It does not shrink like other materials do. It is advertised as having an acceptable taste and odor. I would beg to differ about that, but someday when we get back to lab, you can taste it and you can let me know what you think. The shelf life of this material is about 2 years if it's stored at room temperature. It does have poor tear strength. Water, saliva, and blood will affect the polyether material. Added moisture will increase the marginal discrepancy of this impression, and there's dimensional change with this material is lower than that of other rubber types of impression materials except for addition silicone. To manipulate this product, use a stock tray or a custom tray, a non-perforated tray. Use adhesive as indicated. The adhesive that is manufactured for polyether is the only one that is recommended to be used with this product. You cannot interchange those adhesives, remember. Allow it to dry for only 15 seconds. So remember, polysulfide was 7 to 8 minutes before we place the impression material. This just needs to be in the tray for 15 seconds. Again, do not interchange adhesives. There's a one-step impression that can be made, so we can alter the amount of catalyst to adjust the setting reaction. Increasing the temperature of the room will increase the set of the material, so that means it'll set faster. You need to dispense equal lengths of the same diameter of the base and the catalyst to have the best properties of the final product. Mix the material with a stiff spatula for 30 to 45 seconds. That's all you get to mix enough for that impression tray. It needs to be uniform in color. Then you will load your syringe tip like you did when you were drawing up that material, the green material from the silicone, to load your syringe. Load the remainder in the tray, and then the doctor is going to remove the retraction cord if there was one and inject that syringe material right into the sulcus of the tooth. Doctor will then insert the tray immediately and allow it to set without distortion. So the patient can't talk, can't yawn, can't gag, can't take that impression tray out of their mouth before it sets. Once it is set, we're going to remove it by slowly pulling the tray and having the patient open to break the seal, and then remove in a single stroke to prevent any distortion from happening with that impression. Then you're going to immediately rinse it with cool water, disinfect it, rinse it again, and then blow it dry so that none of that excess water stays onto the impression material. Then we can pour it. We need to wait at least a half an hour, 30 minutes before we can pour it because of the stiffness of the material. So it needs to rebound and has to kind of get back to that original shape. It takes about 30 minutes for that to happen. So while we're waiting for that disinfection to occur, we can use that amount of time for that 30 minutes of rebound. This can be repoured and poured up to 2 weeks without any type of distortion of the product, which is pretty amazing. There's a note here on number 13. It says, do not contact the catalyst with your skin. The person who has added contact may develop an allergic reaction called contact dermatitis. There are some people that are very sensitive to this, and if the person has a known reaction to the catalyst, they shouldn't have this in their mouth either. So if you're a dental assistant and know that this causes you issues, then this would not be the impression material to use on yourself for a crown, a bridge, or inlay. For infection control for the product, follow the manufacturer's instructions. You can place it in a 2% solution of glutaraldehyde for 10 minutes. You do not use bleach on this product or any type of water-based agent because it will soak in and distort the material. Remove it from the glutaraldehyde, and then you rinse it with cold water, blow it dry, and then we send it to the laboratory to be poured and to fabricate the prosthesis that was intended for this procedure. We will come back again and we're going to talk about polyvinyl siloxane.